In a previous video, I discussed the movement of an object projected horizontally. Since this type of projectile moves in two directions, we say that it exhibits motion in a plane, that is, motion in a two-dimensional surface. Planets moving around the sun, the pendulum of a grandfather clock, and a basketball jump shot are all examples of motion in a plane. Let's review the simplest kind of two-dimensional motion. An object projected horizontally. This type of projectile has the same vertical position of an object dropped. This is because they both have an initial vertical velocity of 0. When the initial vertical velocity is 0, we write VIY equals 0. We also know that the vertical force of gravity gives every projectile a vertical acceleration of 9.8 meters per second squared. And when the friction is negligible, we know that the horizontal velocity is constant. Horizontal distance is called dx. Horizontal displacement of any projectile can be found by multiplying its horizontal velocity by the time the projectile spends in the air. Here's a nice illustration of what is meant by the variable dx and dy. dy is a projectile's vertical drop, and dx is the horizontal distance traveled by the projectile. A projectile's horizontal distance is called its range. The picture on the right shows four objects projected horizontally. The objects have different masses and are thrown from different heights and speeds. Which projectile do you think will spend the most time in the air? The first thing you have to realize is that the vertical acceleration due to gravity is the same for all masses, so we can exclude the masses of the projectiles in this question. The other factor we can ignore is each sphere's initial horizontal velocity. The initial horizontal velocity has no effect on how long each projectile spends in the air. The sphere that spends the most time in the air is the one that is launched from the greatest height, and then the one that spends the least time in the air would be the one that is launched from the smallest height. A baseball is thrown horizontally from a grandstand 20 meters above the ground at a speed of 10 meters per second. So VIY equals 0 and AY equals 9.8 meters per second squared. dy is 20 meters because that's 20 meters above the ground, and the horizontal velocity is 10 meters per second. So how long will the ball remain in flight? That's t equals question mark. Since the ball is thrown horizontally, we write VIY equals 0. AY is 9.8 meters per second squared. The height is 20 meters, so we write dy as 20 meters, and we want to find the time, so t equals question mark. On the x side, we know that it was thrown horizontally at 10 meters per second, so Vx is 10 meters per second, and we can put t equals question mark on that side too. Since we have enough variables on the y side of the chart to find an equation, we'll use them. The equation that fits is the fourth one, d equals vit plus 1/2 at squared. When we substitute our numbers into the equation, we find that the projectile spent 2 seconds in the air before it hit the ground. Now let's find the maximum range of this projectile. The range of a projectile is its horizontal distance traveled when it finally hits the ground. It's called dx. Since we want to find the horizontal distance traveled, we can't use anything from the y side of the chart except for the time. The only x equation is dx equals vx times t. We have everything we need to find the range. We were told in the problem that the ball was thrown with an initial horizontal velocity of 10 meters per second, and found out from our previous calculations that the projectile spent 2 seconds in the air. Multiplying these two numbers together, we find the horizontal distance traveled by the object before it hit the ground was 20 meters. This is the end of my second presentation on an object projected horizontally.